Hello students, myself Shashikar ME, a lecturer in chemistry. Today I am discussing a important concept, that is chemical reactions and equations for class 10 standard. Let's begin our chapter chemical reactions and equations. In this chapter, first point we have to know about what is change. Change in chemistry, we will consider one is physical change, second one is chemical change. Conversion of ice into water or melting of ice into water is a physical change. Then how we can define physical change? Yes students, physical change, the physical properties of the substance get change with respect to product. Let's take an example, that is conversion of or melting of ice into water. What is the state of ice? It is solid state. What is the state of water? It is liquid state. And one more point, the properties, physical properties of ice is entirely different from physical properties of water. Yes, then we can understand what is physical change by this example, melting of ice into water. Here physical properties are getting changed. And one more very important point, dear students, that is, so this is the product, this is the reactant. I can bring reactant from the product, water to ice, ice to water. That means this is a reversible reaction. Then what is reversible reaction? That means we can convert product from the reactant, simultaneously we can produce reactant from the product. That is called reversible reaction. Physical change is an example for reversible change. Yes students, I hope you understood what is physical change. Here physical properties of reactant and products are, it will get change. That is called physical change. Example, melting of ice to water. And one more example, boiling of water to vapor. The properties of or physical properties of water different from vapor. It is in liquid state, vapor is in solid state. This is an example for physical change. And dissolution of NaCl in water. NaCl, it is common salt. What is NaCl? It is a common salt. If you dissolve this NaCl in water, it will become solution. This solution, it is in liquid state. NaCl, it is in solid state. The properties of the reactant is different from the properties of the product. Physical properties especially, that is called physical change. Here chemical composition change ಆಗ್ತಾ ಇಲ್ಲ, but only physical properties are changing. This is called physical change. These physical changes are reversible reaction. That means from ice to water, from water to ice, water liquid state to solid state, gaseous state, simultaneously gaseous to liquid state. Clear? Yes, this is about physical change, dear students. Next we will understand what is chemical change. What is chemical change? We will understand this chemical change by an example of burning of natural gas, that is LPG. Burning of natural gas, that is LPG, liquefied petroleum gas. This liquefied petroleum gas, which contains few alkanes, burning of alkanes, it is chemical change. Curdling of milk, one more example, curdling of milk, milk will get converted to curd. The composition of milk and curd are different. Then by these example I can define chemical change. Here chemical composition of the reactants are changing compared to product. That means the composition of reactants are different from the composition of the products. So these are the best two example for chemical change. And this chemical change, see, just observe here, we can make milk from the we can make curd from the milk. Curdling of the milk. Reactant is the milk. Product is the curd. We can convert milk to curd. The composition of milk and curd are different. Simultaneously, if you converted milk to curd, again curd to milk is not possible, dear students. That is why these chemical change or chemical reactions are irreversible reactions. Yes, dear students, we understood what is physical change, what is chemical change. Simple state na nodi first. If it is converted to solid to liquid, obviously physical properties change agate, and it is reversible reactions. Chemical change, chemical compositions change agate, and one more point, and that chemical change is irreversible reactions. This is about change. Next, the basic concept of chemical equations and reactions, that is about chemical equations, and you should know about oxidation states. Let's begin with the oxidation state. Yes. Yes, students, you might heard about atomic number, atomic mass, valency, valence electrons. First, you should know about what is atomic number. Atomic number, which is the first element in the periodic table, it is hydrogen. Atomic number of hydrogen is 1. Atomic number of hydrogen is 1 means which contains 1 electron and 1 proton. Electrons are negatively charged particles. Protons are positively charged particles. Helium atomic number is 2. If helium atomic number is 2 means which contains how many protons? 2 protons. That means 2 positively charged particles and 2 electrons. Lithium atomic number is 3. That means which contains 3 protons and 3 electrons. In chemistry, dear students, plus means minus, minus means plus. Sir, what is that? Helium atomic number is 2. If I write He plus, it is plus, He plus, that means helium atomic number is 2, there are 2 protons, there are 2 electrons. In helium, which lost 1 electron, this is plus 1, that means which lost 1 electron, I can say He plus contains only 1 electron. Lithium atomic number is 3. If atomic number is 3 means which contains 3 electrons and 3 protons. Li plus means you have to remove 1 electrons from these 3 electrons. It will become 2 electrons. Simultaneously, if I write Li2 plus, Li 3 electrons, Li plus 2 electrons, Li2 plus which contains only 1 electrons. So this is the basic information about plus minus, removal of electrons. If I write, let's take an example of if I write H minus, that means extra one electron. Hydrogen atomic number is 1, which contains 1 electrons. H minus means which contains one more extra electron, that is, now it has 2 electrons. Simple, dear students. In chemistry, plus means you have to take plus 1 means extra electron, minus 1 means plus 1 means you have to remove one electron simultaneously. Minus 1 means you have to add one electron. This is the basic information about plus charge and minus charge. Let's begin our chapter with balancing the chemical equation. With balancing the chemical equations. Yes, students, let's study about balancing the chemical equations. Let's take an example of, very important example of KNO3 gives rise to KNO2 plus O2. Now, this is the reaction. In the left hand side, only 1K, in the right hand side, only 1K. In the left hand side, only 1N. In the right hand side, only 1N. In the left hand side, there are 3O, but in the right hand side, sir, what is this? Half O2 means half O plus half O, together 1O. Very important, dear student, this is. Few elements, those are available in gaseous states like H2, O2, N2 and Cl2, Br2, I2. These are the elements, they are available in the gaseous states. That's why we always write these elements in the diatomic state. Look here, we should not write H instead of that H2. We will not write O instead of that O2. We will not write N2 instead of that N2. Cl ಬರೆಯೋಂಗಿಲ್ಲ, we should write Cl2. That is why they wrote of O2. 1O plus 2O equals to 3O. Let's take few more examples to balance the chemical equations. First, dear students, I will give you a trick, that is, first point, balance other than oxygen atom and hydrogen atom. ಫಸ್ಟ್ ನೀವು ಮಾಡಬೇಕಾಗಿದ್ದೇನೆಂದರೆ ಆಕ್ಸಿಜನ್ನು ಮತ್ತು ಹೈಡ್ರೋಜನ್ನ ಬಿಟ್ಟು ಬೇರೆ ಎಲಿಮೆಂಟ್ನ ಫಸ್ಟ್ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಬೇಕು. Let's take an example of few reactions. H2 plus Cl2 gives rise to HCl. Students, I told you that first balance other than oxygen and hydrogen, H2, Cl2. Here first balance this Cl2. So here they didn't wrote half. That means we will take 1 into 2, 2, 1 into 2, 2. You just write 2 HCl here. There are 2 Cl. Now 2 Cl. Cl is balanced. There are 2 H on the right hand side. There are 2 H on the left hand side. Now look a very important point. Why we have to balance the equation? What is the necessity to balance the equation? I will tell you that. Then I will take one more example of CaCO3 gives rise to CaO plus CO2. Now look here, student. First you have to balance calcium, this side 1, this side 1. Carbon, this side 1, this side 1. Oxygen 3, 2 plus 1, 3. Left hand side is equal to right hand side. Because we need to balance the chemical equation, because one law is there, that is law of conservation, law of conservation of mass, law of conservation of mass. What it says, the mass of the reactant should equal to mass of the product. Mass of the reactant should equal to mass of the products. I will tell you how to calculate mass of the molecules. If the atomic number is even number, just multiply with 2. If the atomic number is odd number, multiply with 2. After that, you need to add 1. Carbon atomic number is 6. It is even number. Multiply with 2, you will get 12. Then I will take one more example of lithium. Atomic number is 3. It is odd number. Into 2 plus 1. Atomic mass will be 7. Now, calcium atomic number is 20. Atomic mass 20 is even number, 40. Carbon atomic number is 6. Atomic mass will be 12. Oxygen atomic number is 8. There are 3 atoms. 8 into 3, 24. 8 into 3, 24. But we should write, carbon atomic mass will be 12. Oxygen atomic number is 8. It is even number. Atomic mass will be 1 atomic mass 16. There are 3 atoms, hence 48. 48 plus 12, 60 plus 40. This equal to 100 gram per mole. Here oxygen 16, calcium 40. 40 plus 16. This is equal to 56. Here carbon 12, oxygen 32. 32 plus 12, this is equal to 44. 64 plus 44 equal to 100. This is said by law of conservation of mass. So, the mass of the reactant should equal to mass of the product. Reactant mass of 100, product mass of 100. Now this is a balanced chemical equation. That is why we have to balance the chemical equation. Reactant side mass should equal to product mass. That will be given by law of conservation of mass statement. Yes, students, let's practice some few more chemical equations to balance the chemical equations. Let's take few more practice examples. FeH2O gives rise to Fe3O4 plus H2. N2 plus H2 gives rise to 2NH3. First, I told you that balance other than oxygen and hydrogen, there is only one F in the left hand side, but there is 3 Fe in the right hand side. That is why you have to balance Fe first. Just 3 add madu. Then this side 3 Fe, this side 3 Fe over. Next, this side there are 4 oxygen. How many oxygen? 4 oxygen in the left hand side. You need to add those 4 H2O. Number of oxygen 4. The same number of H2O you need to add on the left hand side. Now, how many hydrogen? 4 into 2, 8. 8 H. N2 plus H2 gives rise to 2 NH3. In the reactant, how many H? N2? 2. In the product, there are 2N. In the reactant, how many H2? Or how many hydrogen? 2. But in the product, dear students, 2 into 3, 6. 3 into 2, 6. It is balanced. Very simple. Other than oxygen ಮತ್ತು hydrogen na first balance ಮಾಡಿ, then afterwards we balance oxygen first, then hydrogen. This is about balancing the chemical equations. Now I will tell you, now we are going to study about combination reaction, decomposition reaction, displacement reaction, double displacement reaction and redox reactions. Let's begin with some basics. Let's begin with some basic, dear students, that is combination reaction. Before that, I will tell you how to write, how to name the compounds. Yes, let's begin with an example of NaCl. Let's take an example of NaCl. So, ಇದನ್ನು ಹೇಗೆ ನೇಮಿಂಗ್ ಮಾಡಬೇಕು? Means Na is sodium, Cl is Cl minus chloride, sodium chloride. If one metal and one non-metal present in the compound, then that should end with IDE, sodium chloride. Potassium metal, KBr, potassium bromide, that should end with IDE, potassium bromide. Let's take an example of one more example, that is MgO. What is MgO? One is metal, second one is non-metal. I can write it as magnesium oxide. What is this? Magnesium oxide. Very important. Don't forget the oxide. Very simple, dear students. Metal ಮತ್ತು non-metal ಇದ್ರೆ that should end with IDE. Sodium chloride, potassium bromide, magnesium oxide. Sir, if both are non-metals, then how we can write the compounds? Yes, both are non-metal means, example PCl3. Phosphorus non-metal, chloride non-metal. Now very simple, phosphorus trichloride, I will take off PCl5, phosphorus pentachloride. SO2, both are non-metals. Sir, ಎರಡು ಹೆಂಗೆ non-metal ಅಂತ ಗೊತ್ತಾಗುತ್ತೆ? Sulfur, oxygen, ಅಂತ ಬಂದರೆ generally that will be metal. Sulfur, oxygen, both are non-metals. Hence, sulfur dioxide. What is this? Sulfur dioxide. Clear, students? Metal and non-metal, that should end with IDE. Non-metal along with non-metal, generally we will write as it is along with di, tri, penta, tetra. So this is about just introduction about how to name the compounds. Next, I will tell you very important that is very important thing, that is how to write the compounds. How to write the compounds, you have to learn this: hydrogen, lithium, sodium, potassium, rubidium. Generally valency is 1, oxidation number is +1. Oxidation number, it varies, it depends on the compound, but generally oxidation number will be +1. Beryllium, magnesium, calcium, strontium, generally oxidation number +2. In that side, very important, boron, carbon, nitrogen, oxygen, fluorine, aluminium, silicon, phosphorus, sulfur, chlorine, bromine, iodine. These are the main important compounds. +3, 4, -3, -2, -1. Fluorine, chlorine, bromine, iodine, they have oxidation number -1. Makla, generally the compound should get neutral charge. Example, I wrote NaCl, sodium metal, chlorine non-metal. What is the oxidation number of chlorine? It is -1. Sodium +1. +1 -1, 0. Hence NaCl, we will write it's a salt which contains 1 cation, 1 anion, it will get neutral. I will take an example of one more example, that is magnesium sulfate or magnesium oxide. The oxidation number of magnesium is -2, oxidation number of magnesium is +2, oxidation number of oxygen is -2. I will take one more example, NaO. This is -2, this is +1. Now you have to send this 2 to here, it will become Na2O. Na2O. I hope you understood how to write compounds. Let's practice few more example. That just example I will tell you. AXBY. You have to send this X to here, XA. You have to send Y to here, YB. This Y should be on A superscript, Y plus. This X should be on B superscript. Now X into plus Y into X, that is equal to plus XY. Here -X into Y, that is equal to -XY. This is the method to write charge. I will take an example of Al2SO4 thrice. Al2SO4 thrice. You just send this 2 here, you just send this 3 to here, it will become 2Al3SO4. Simultaneously, this 3 or this 3 should be on the superscript +3, this 2 on the superscript of here minus. 2 into +3 +6, 3 into -2 -6, it will get cancelled, 0. So this is about how to write compounds. I will take an example of one more example, that is Na plus PO4 3 minus. Yes. You have to send this 3 to here, this 1 to here, it will become Na3PO4, sodium phosphate. And one more example I will take, that is Mg2 plus Mg plus 2 PO4 3 minus We have to send these 3 to here, 2 to here. It will become Mg3PO4 twice. Clear students? This is the method to write compounds. Oral charge 0 ಆಗಬೇಕು. You should always keep in your mind. So this is about just introduction about some basic concept of chemistry, and now I will teach you exactly the chapter, that is chemical combination. Yes, dear students, chemical combination, it's a combination reaction. What is combination reaction? If two or more reactants combine to form a single product is called combination reaction. Let's take an example of H2 plus Cl2 gives rise to 2HCl. Two reactants combine to form a single product is called combination reaction. Product should be one. Product should be one. And very important, N2 plus H2 gives rise to NH3. Can you balance this equation, dear students? 3H2, 2NH3. N2, N2, 6H, right hand side 6H. Very simple. Look here, students. Two reactions combine to form a single product. I will take one more example of, I will take one more example. NH3 plus HCl, two reactants combine to form a single product is called combination reaction. Generally, I can say it as two or more reactants combine to form a single product is called combination reaction. Then what is decomposition reaction? It's a reverse of combination reaction. What is decomposition reaction? If reactant gets into simpler products, if one reactant gives more than one products, that is called decomposition reaction. It's a reverse of combination reaction. Let's take an example of, this is combination reaction. Let's take an example of decomposition reaction. Let's take an example of decomposition reaction. You might heard about limestone. That is limestone, CaCO3, calcium carbonate. Limestone, when it absorbs heat, it will get converted to CaO plus CO2. Calcium oxide and carbon dioxide. The one reactant get converted to simpler units or simpler products or more than one products are called decomposition reaction. Here very important, here I wrote heat. What is that? In a chemical reaction, if it absorbs the energy, if it absorbs the heat to form the products. For example, we have water. We are heating this water. That means we are providing temperature from outside. We are providing temperature from outside to the beaker. Now this water will get vapors. Very important thing, dear students, here we are providing energy to convert water to vapor. That means this beaker or water absorbing energy, that means it is an endothermic reaction. What is that? An endothermic reaction. If a reaction releases heat, that is exothermic reaction. Combustion, you might heard about combustion of fuel. I told you that combustion of LPG gas, combustion of or combustion of alkanes, we will get CO2 plus H2O along with release of energy Generally, we will write energy in kilojoule. If the energy produced heat is liberated during the chemical reaction, that is called exothermic reaction. Just imagine this room. If heat coming into the room, that is endothermic. If heat going out of the room, that is exothermic reaction. Very important question, my dear students. Fishes are more comfortable in cold water than in hot water. The reason for that is, I will tell you. Yes, we have a lake here. We have O2, N2. This O2 is soluble in water. That dissolved oxygen used for respiration by the fishes. So I told you that we have a lake. It contains water. This O2 present in the atmosphere will get dissolved in this water. That dissolved oxygen used for respiration by the fishes. This O2 dissolution in the water is exothermic process. That means that releasing heat from the outside. If you increase the temperature from outside, heat always flows from high temperature to low temperature. If you increase the temperature from outside, heat coming into the system or from outside to inside. Now, dissolution of oxygen in water decreases. If dissolution of oxygen in water decreases, availability of oxygen for respiration for fishes, it is decreases. So, ಹಾಗಾಗಿ hot water ಅಲ್ಲಿ dissolution of O2 is very less because that is exothermic reaction. We are providing temperature from outside, the O2 solubility is decreases, hence the availability of oxygen for the fishes decreases. That is why fishes are more comfortable in cold water than in hot water. Yes, dear students, we understood about exothermic reaction and endothermic reaction. During chemical reaction, heat releasing outside, exothermic reaction. If during chemical reaction, heat coming into the system, endothermic reactions. Best example for exothermic reaction, combustion of fuel, combustion of alkanes. Yes, dear students, till now I told you that, can you say, this is combustion reaction. And single product converted into many products, single reactant converted to many product. That is why this is decomposition reaction. Generally, this decomposition reaction occurs in presence of light or some amount of heat or energy required to convert reactant into product. Yes, dear students, till now what I told means you have learnt about change, physical change, chemical change. Then example for those change, chemical change, chemical compositions will getting changed from the reactant to product. This should be balanced according to law of conservation of mass, because it says that reactant should equal to reactant mass, reactant weight should equal to product mass. Sir, what is the difference between weight and mass in chemistry? I will tell you. W is equal to m into g, weight is equal to mass into gravity in physics. In here we are dealing with electrons, protons and neutrons. That is why we will take gravity as constant. Hence, W is equal to m, m is equal to W, weight is equal to mass, mass is equal to weight. Atomic mass and atomic weight both are same. After that, we were studied about to balance the chemical equations. We took some examples. After that, we were studied about combination reactions and decomposition reactions. Yes, students. I will wind up the session here today. I will continue with the next session with redox reactions, very important reaction, displacement, double displacement, rancidity, and we will metals and non-metals. We will complete the chapters. So I hope this session will be very helpful to you. Please subscribe to our channel and share to your friends. Thank you.